Imagine training a massive language model on billions of web pages, but most of them are junk. How do you filter the good from the bad without checking every single one? Enter TBDFILTERING, a smart, sample-efficient way to curate training data using text embeddings and hierarchical clustering. Here's how it works. First, we turn every document into a vector using a powerful embedding model, like Gecko. Then, we group similar documents into a tree-like hierarchy, where each branch represents a cluster of semantically related content. Now, instead of evaluating every document with a large LLM, which is expensive, we use a clever adaptive strategy. We start at the top of the tree. We sample a few documents from each cluster, prompt an LLM to score them, and estimate the cluster's overall quality. If the average score is clearly high or low, say, above 0.6 or below 0.1, we classify the entire cluster as keep or discard. But if it's ambiguous, we split the cluster and drill down into its children. This process continues until we've made a decision for every document, but with far fewer LLM prompts than a naive approach. The math behind it. Under mild assumptions that the data has natural structure, the number of prompts needed scales with the inherent complexity of the data, not the total size. In theory, you can get near-optimal filtering with just a tiny fraction of evaluations. In practice, we tested it on 3 massive datasets, C4, ThePile, FineWeb, training Gemma 3 models from scratch. The result? Models trained with TBDFILTERING outperformed baseline models by 1 to 5% relative improvement across 8 key benchmarks, including ARC, MMLU, and BookQA. And it beat even state-of-the-art classifier-based methods, without needing to train a separate student model. Bottom line, TBDFILTERING gives you high-quality data at scale, efficiently, adaptively, and without the overhead of massive retraining. It's not just smarter filtering, it's smarter training.